Hello, in this video we are going to learn the ICMP protocol, the Internet Control Message Protocol. As you may know, IP protocol doesn't guarantee that a packet successfully arrives to the destination. So we need another protocol to help IP to notify that there are some problems in the network related to error checking or error reporting because of an unreachable host or an unreachable network port or protocol. So this protocol, ICMP, is used in order to notify hosts and router that there are some problems in the network, let's say. We have a packet, an IP packet as usual, with the IP header. An ICMP packet is encapsulated inside the payload. So the question is, how can we know that an ICMP packet is encapsulated inside an IPv4 packet? Well, as usual, the protocol field inside the IPv4 header tells us that the specific payload type is an ICMP packet. Moreover, an ICMP message or packet is composed of a header and a payload. So in the next slide, we will see the different fields for the header and what's the type of payload we can have in an ICMP packet. Here in this table, we have information of potential ICMP messages, but I prefer to move to the next slide in order to understand which is the shape and the format of an ICMP packet. So here we have an IP packet that is composed of an IP header and the IP payload. So here we can have a TCP segment, UDP datagram, or in this case, an ICMP packet. Protocol field is set to 1. That tells us we can find an ICMP packet inside the payload. So there is an ICMP header and ICMP payload. So which are the fields for the ICMP header? We have 3 fields. Field type that tell us which is the type of the ICMP packet. Field code in order to extend the explanation of the type field. Checksum field in order to check some errors in the header of the packet. And finally, after the checksum field, we can have other specific information regarding the type of message. For example, imagine that we want to do a ping from our computer, this is the source host, to the destination host. The purpose of pinging a destination host is to know if it is reachable or not, if it is working, if it is connected to the internet. So when pinging the destination, I send an ICMP packet of type 8, which is an echo request, and if the destination sends me a response, a reply, I receive an ICMP packet of type 0. This is the echo reply. So in this specific example, when ping application is explored, we have the combination of 2 ICMP packets. One of type 8, echo request from source to destination, and one of type 0, echo reply from destination to source. Let me introduce another type of ICMP packet. In this case, we are going to explore let me erase this, type 3 destination unreachable. So if this type of message is used, it means that we cannot reach a specific destination. For example, maybe the problem is the network. We don't know how to reach the specific network, or maybe we don't know how to reach a specific host, or because of the protocol, or there are problems with the port. So in this case, the type is 3, but the type only tells us that the destination is unreachable. But which is the problem? Which is the motivation of the unreachability of the destination? So then we have to explore the code field. If the code field is 0, the network is the problem. If it is 1, the host, and so on and so forth. So this is a very good example to combine type field with code field. Another type of ICMP message is type 4, source can't. It is related to congestion. Imagine we are a router and we are receiving traffic very fast, and we cannot handle the traffic because we have problems with our buffer because it's feeling full. So I can create an ICMP message to the source that is sending the traffic in order to say, stop, wait a minute, like the sun. I cannot handle all the traffic, and this type of message is an ICMP packet of type 4. But this type of message is normally not used because if we are experiencing congestion in the network, maybe it's not a good idea to create an ICMP packet to be sent from me to the source host, because in this case I'm increasing the congestion. So the congestion control is handled by the transport layer that we will see in the next lecture, basically on TCP protocol. Another type of message that is useful is type 11, time exceeded normally because of a TTL expiration. So when the TTL is decreased on a router and it is set to 0, there is imagine this is the router, and the packet traverses the router, TTL is decreased by 1, so it is set to 0. An ICMP packet of type 11 is sent to the source to say, okay, your packet has died, and you have to decide if retransmitting again or not. And a very interesting application of ICMP type 11 is the execution of the traceroute command. On the traceroute, we type on the terminal traceroute, let me use TR, like the invocation of traceroute, and the destination host. The main goal of tracerouting a destination host is to know the path from the source to the destination and how to know it. So the idea is to force the expiration of the TTL by sending packets from the source to the destination first with TTL set to 1. If we send a packet with TTL set to 1 to the destination, once it is received by the first hop, the TTL is expired. Then this router will notify the source host that this is an ICMP packet of type 11. Your packet has died and you have to decide what to do with it. But the main goal here is to know the specific IP address of the first hop, because on this packet, the source host is the one for the router. Then this process is repeated 3 times, 3 packets with TTL equal to 1. Obviously, we will have the same information, but we have 3 different times in order to have an average round trip time to reach the first hop. If we want to know now the information about the second hop, we have to send another message or another 3 messages with TTL set to 2. In this way, when these packets arrive to the first hop, the packet TTL is decremented by 1, and then when it is reached by second router, TTL is set to 0, and then a new ICMP packet of type, here we have type 11, of type 11 is sent back to the source. And this way, we can know which is the specific IP address and the time to go and come back from the source to the second hop. And this process is repeated up to reaching the final destination. How can we know we have reached the destination? Because the ICMP packet that is sent from the destination to the source host is of type 3, code 3. So the process is stopped. That's a summary. How traceroute works with ICMP protocol to assess the path from a source to a destination. The process is as follows. We send 3 packets with TTL set to 1 in order to know which is the first hop. Then 3 packets with TTL set to 2 in order which is the second hop. And in this way we can reach the destination. Once we receive an ICMP packet of type 3, code 3, we have reached destination and we have the whole path from the source to the destination.